Hello everyone, this is Mr. Rob and you are going to watch a video about energy and motion. That's the subject that we're teaching, and it's going to be kinematics in 2 dimensions. Basically we're going to talk about parabolic throw and vertical throw. This is the topic for today. Now you may see this guy. This is called a hammer. This guy is throwing a projectile, and most likely, or exactly, this will happen. It will go in a parabol, right? In a parabola, like this, parabolic throw, and we're going to study this, and also just throwing something up and down, like that, upwards, and then how it will fall. So let's start with this. Let's describe the two kinds of motions. So here is, for now we have been describing the motion, that's kinematics, and now we'll worry about explaining the motion of later, like dynamics. But this is what we'll do. Projectiles. So a projectile is an object moving in 2 dimensions under the influence of gravity. It's throwing an object, and it will be the only forces that will be being applied to this object will be just gravity. In this case, we will neglect a resistance. Neglecting means that we're not going to take it into consideration. So we will think that there will not be any air resistance while throwing a projectile. But let's talk a little bit about what is air resistance. Air resistance is the opposition of the air, when we have air, of the motion of an object. The effects of air resistance is to slow down an object and or decrease its acceleration, and we already talked about this on the previous video. And here you can see that you have the weight of this person plus the weight of the parachute also, but the air resistance is pushing up. And we talked about also terminal velocity, which will be when these two forces are equalized, then the velocity will be continuous and there will be no more acceleration, and that is called the terminal velocity. Now there are some turbulences and some shapes that have better aerodynamics, like for example this one here in the center has better aerodynamics. This could be like the cross section of the wing of a plane. We can see that a sphere has some vortex here on the back. Vortex is these little things that go here. Of course, a wall will have many of them. Now, projectile motion is the motion of an object projected into the air at an angle. We have a person here being shot out of a cannon. So boom, it goes like this, and here you can see the parabolic motion of this. So it's, if you check it, those equations that you learn in math, well, here they are applied here. The moment that this guy goes out of this cannon, it's only the only force that is pulling him downwards is gravity. Let's see if this works. And this is an example of what you can call a parabolic throw to the extreme. So here it goes. There's a guy, a ramp, and that is mathematics. Do you see the little pool? that is mathematics. This is real. It's not it's a project that they did in Europe. You can catch them and see them later. Very happy, right? Well, they're megawhoosh.com. You can go and see how they made this project. So projectile motion. The horizontal motion has constant velocity. That this means that, for example, here you can see that the horizontal is this one here, like horizon, right? So this, when you throw something, the horizontal velocity will not change. You see, it's the same. The blue ones here, the blue arrows, will remain the same. So it will start with one velocity and it will keep that horizontal velocity all the time. Now, if you remember, acceleration is the change in velocity. So if you have constant velocity, you will have acceleration equals to 0. Basically, this is what it is. Vx is going to be like any velocity in x will be the same as the initial velocity in x. And also, we will have an acceleration of 0 because there are not any forces pulling this in the horizontal direction. Now the vertical is a different thing. You will start with a high velocity, which will be the same as the coming down. So if you take here on the same level, if you check the velocities, the velocity going upwards will be the same as the velocity going downwards. Same thing here, same velocities, and it has a characteristic. When you throw something upwards, this will go up, and it will gravity will go down, of course, so the velocity will shrink. You have a downward acceleration, and do you remember which one was that? Yes, acceleration will be downward, and it will be 9.81 meters per second, or 32 feet per second square. It's both squares, second square. So it's 9.81 meters per second square, and or in the English or British system, 32 feet per second square. Now it will go diminishing, right? So we'll be stopping, so you have a negative deceleration until you have at the top, at the very top, you will have a velocity of 0. This is a very good point because we can we can use this to make our equations easier to solve the problems. Now, it will start gaining velocity again. So it's from 0, it will start gaining each second 9.81 meters per second. It will increase the velocity and so on, the second, third, etc. So we have Galileo here to help us. He's watching us, seeing this. So horizontal throw. Horizontal throw is very simple. We are going to divide this in two. So the projectile experiences a constant acceleration downwards due to gravity, 9.81. The downward force of gravity causes vertical velocity to change uniformly. So basically it's this. Here, this ski jumper has a lot of velocity, but it has 25 meters per second horizontal velocity. So it will continue with the same velocity here, here, and here. And if it goes into a hole, well, then it will continue with the same horizontal velocity. We already said that. But in y, it starts with 0 because in y it's not falling. So here it starts to fall. It starts to fall. So on the first second, again, it's going to gain a little bit more of velocity going downwards, right? And basically, what we will have is these equations. The velocity in y will be like final velocity. Remember the equations is equals VO y, meaning the velocity of in y, the original one in this case was 0 if we take it from here, from the top, and g, which is gravity acceleration times time. And this is the second equation we saw, right? Now the same velocity it can be calculated here, and if you remember vectors, we have 25 in x and whatever velocity we have in y, and we can get the resultant velocity with this angle, okay, or the absolute angle from here, from the x-axis starting from the x-axis to the vector. Now, also, well, we know this, right? The distance y is the distance will be 1/2 of gt squared. Why? Because of the first equation, we also have a zero velocity in y, so we cancel the first term, and we have 1/2 of gt squared. Now, what is the distance in x? In x, we said that we had constant velocity, meaning that we don't have any acceleration. Meaning that if you get the first equation, distance equals VOT, right? In x, VOXT plus 1/2 of GT squared. If we don't have, or not G, but acceleration, we don't have acceleration, so we cancel the second term. We will be left with this. Distance in x will be equals to the initial velocity, in this case 25, multiplied by the time in which you will calculate that distance. And that's basically it. Presentation by your teacher, Mr. Rob. Thank you very much. See you in class. Bye bye.